Here's a reminder of what your notes should look like for 8-5, factoring special products. Just a side note for this section, 8-5, factoring special products, we will not cover perfect squared trinomials. We are only going to cover a difference of two squares. What is a difference of two squares? For this video, we will answer that question. And this is going to be video number 1 for this section. A perfect square is a number whose positive square root is a whole number. Some examples of perfect squares are shown in the table. So this is an example of all these perfect squares. These numbers will be considered perfect squares because they can be split into a number that is squared. So 25 could be 5 squared, 49 is 7 squared, 64 is 8 squared. So these green numbers here are called perfect squares. This is a review from chapter 1. I actually got this table from chapter 1, and I wanted to go ahead and review perfect squares with you because for difference of two squares, you'll have to identify which numbers are perfect squares. A polynomial is a difference of two squares if there are two terms and they're both subtracted from each other. So notice it can't be added to each other. They must be subtracted from each other. We should probably underline that information. And don't forget, you should write down all this information and then play the video to follow along. And both terms are perfect squares. So we have an example of that. 4 squared can be split off into 2 squared times 2 squared. Remember, when you multiply the x's, you get x squared, but when you multiply the coefficients, you get 4. And then for 9 can be split off into 2 equal pairs, 3 and 3. So both are perfect squares, and there's that difference, that subtracted part that we were talking about in the middle, and this is a difference of two squares, and we can apply the shortcut that's for this video. Okay, I have 3 examples. 2 of them I will do with you and 1 for you to try on your own. So what we're going to do for these 3 examples is we're going to determine whether the binomial is a difference of two squares, and notice it has to be a binomial. There's only 2 terms. And if it is, we're going to have to justify, or if it is, we'll justify our response. If it's not, we'll also justify why it is not a difference of two squares. So notice that we have to look at both terms. We have to look at the first term and the last term. So let's take a look at the first term. We have 3p squared. I can't split that off into 2 equal factors, so I'm just going to leave it. But the 9q to the 4th power, we can. We can split that off into 3q squared times 3q squared would give us the 9q to the 4th. Therefore, this is not a difference of two squares because both terms have to be perfect squares. Notice the sentence I have at the bottom of the screen. 3p squared minus 9q to the 4th is not the difference of two squares because 3p squared is not a perfect square. Not only did I answer the question, but I also justified the response for this example. This is how you should be doing the next 2 examples. Once again, same rules. We're going to determine whether the binomial is a difference of two squares. And if so, we're going to justify our response. And if not, we'll do the same. We'll justify our response. So let's take a look at 100x squared. Notice this is a binomial, and they're subtracted from each other. So now we'll check if it's a difference of two squares. 100 squared can be split off into equal factors. 10 squared, 10x times 10x, excuse me. And then negative 4y squared can be split off into 2y multiplied by 2y. Therefore, the polynomial is a difference of two squares. And we're going to use the sentence stem at the bottom of the screen. We should try to look at the previous example to see what we would put here. So, the binomial, which is 100x squared minus 4y squared, is the difference of two squares because 100x squared and negative 4y squared are perfect squares. And here's our last example. You're going to do this one on your own by yourself using the previous 2 examples that we just went through. Determine whether the binomial is a difference of two squares. Justify your response. Here's the binomial. It's a little bit backwards, but the same idea and principle and concept still apply. So check to see if it's a difference of two squares. And if so, I'd like you to write your sentence stem down at the bottom and explain why it is not a difference of two squares.